solving linear equations. Hopefully all the material in this particular lecture will be very familiar to you and just to help you get up and running and remember some of the terminology. So an equation is when you have an expression equal to another expression. It is important that you have an equal sign if you have an equation. For example, 6 equals x plus 2 isn't an equation. Equations can be true or false, and what we define as being the solution to an equation is the value of the variables that make the equation true. So x equals 4 is a solution to this particular equation because if we substitute 4 into the equation for the variable x, we get a true statement, 6 equals 4 plus 2. Some equations have more than one solution. The equation x squared equals 4 has two solutions, either positive 2 because 2 squared is 4, or negative 2 because negative 2 squared is negative 2 times negative 2 equals positive 4. And then some equations have no solution. X plus 2 equals x subtract 3. If we try solving, we end up with a false statement. So there's no solution to this particular equation. Techniques we use to find solutions include adding and subtracting the same value to both sides of an equation, multiplying and dividing the same value to both sides of the equation, and there's many others. In general, we're doing opposite operations in the opposite order in order to isolate the variable. The golden rule when solving equations is to keep the equation balanced by doing the same thing to both sides. Simplest equations to solve are linear equations. There's one variable, and no powers. So for the example, 2x subtract 3 times x plus 6 equals 7 to solve, you can think of this as being 2x plus negative 3 and distributing the negative 3 through the parentheses. 2x subtract 3x subtract 18 is 7. Combine like terms, isolate the variable, and we get our solution. For the equation x over 4 subtract 5 equals 1/2. This is a linear equation that has fractions, and if we multiply both sides by the least common denominator, the LCD of the fractions in the equation, we can do what we call clearing fractions. That simplifies the equation to x subtract 20 equals 2. It's fraction free, and then it's very simple to solve for x after that. This equation looks like a quadratic equation rather than a linear equation, but we can see as we go through the simplification process it does turn into a linear equation. So just a reminder, we can FOIL. X times x is x squared. X times negative 4 is negative. Subtract 4x, 4x, and 4 times negative 4 for the subtract 16. And then we can distribute the 5 through the parentheses. Actually, we combined like terms here first, didn't we? Those canceled out, and then we distribute the 5 through the parentheses. And then over here we simply FOILed, and then when we start combining like terms, we see the x squared terms on both sides cancel each other out, leaving us with a linear equation that we can then solve. Literal equations have multiple variables, so we're not really solving in the sense that we're coming up with an answer in the form x equals 2. What we're doing is really rearranging the formula. So volume equals length times width times height is a formula for the volume of a rectangular box. And if we want to solve for the height h, what we need to do is peel off the variables we don't need, the L and W. They're joined by multiplication to the h, so the opposite of multiplication is division. Divide both sides by the L and W, and we've isolated the h. H equals V over L times W. So again, what we're ending up with is a formula rather than something that looks more like a familiar solution, like a number answer. Our second example here, 1 over 2a equals 1 over b. We can clear fractions again. Our LCD in this case is 2ab. Once we multiply both sides of the equation by 2ab, we're looking at b equals 2a, and then we simply need to divide both sides by 2 to isolate the a. And there's several correct ways you can write this. 1/2 times b, 0.5 times b, b over 2 are all the same way of saying a equals b over 2. Our third example here has got a little bit of a trick to it. Our LCD is x, y, z, so we can still clear fractions, but we're solving for the variable y. And you can see after we clear fractions that the y is in two different places in our equation. So what we're going to do first is get both terms with y on the same side of the equation. They won't combine because they're not like terms. But once we have them on the same side of the equation, we can factor out the common y and get y times z subtract x equals xz. And we can divide both sides by the z subtract x to isolate the y.